Evaluating and graphing polynomial functions. Here we go. The leading coefficient can't be 0. You'll see in the examples why it can't be 0. The exponents have to be all whole numbers. So we're not dealing with negative numbers. And we're not dealing with, or I shouldn't say negative numbers. Exponents can't be negative. As well as, you won't see any imaginary exponents. Coefficients have to be real numbers. So any kind of coefficient you see, we're not dealing with imaginary. So, the leading coefficient's going to be the coefficient that's in the front of the polynomial. The constant term will be that number hanging out. This n is going to be the degree. So whatever the highest exponent is, that'll be the degree of our polynomial. And standard form of this equation will be written where its terms are written in descending order of exponents. Here's the polynomial written in a different way. If you want to copy down that table, that's up to you. Identifying polynomials. So because A fits all the rules, it is a polynomial. If it's a polynomial, let's write it in standard form though. We got to go in decreasing order by powers. So what term should go first? So be careful. It's got to be, we're going to say negative. So negative 3x to the fourth. What goes next? And last but not least, the constant term, minus 7. We need 3 things. After writing the function in standard form, we need degree, type, and leading coefficient. I'm going to use a sub n to represent the leading coefficient. Degree? 4, agree. What do you call it? Actually, learn that word. Yeah, it's quartic. And then leading coefficient. Not a poly. Cannot have a negative exponent. Standard form. Since x squared is the biggest coefficient, or sorry, x squared is the biggest term, biggest degree, it goes first, then the linear term, then the constant term. Degree, hopefully you already wrote it down. Type, we know that. And leading coefficient. Woot woot! We're going to put a little box and then a line. We're going to stick that 3 inside the box, since that's what we're trying to find. And then we're going to write down the coefficients in descending, or the coefficients, as long as it's in standard form, the way you see them. But here's the problem. Notice how we're missing a term. What term are we missing? We're missing the cubic term. So to hold that place value, I'm going to insert a 0 x cubed right here. So when I write down my coefficients, I'm going to put 2, 0, then negative 8, 5, negative 7. Question?
You put the 3 in the box because that's what we're looking for.
3 is in the box because that's what we're looking for. We drop down the first coefficient. The leading coefficients gets dropped. We are going to multiply whatever number is down here times the number in the box. 2 times 3. We write it in the next column. Now we're going to add the columns. 0 and 6. 6, I heard it. Now we're going to take this number down here and multiply it by 3. And we write that product beneath the next column. We add, multiply, then add, multiply, then add. So since we just added, we're going to multiply 10 times 3, and then add. Multiply 35 times 3. Can we do that? What is that, 105?
Wait.
No. Is it?
Yeah.
And then negative 7 and 105. 98. Did anybody already plug in f of 3? Because if you plug in 3 into your calculator and put it in that polynomial, it does come out to be 98. What's all missing? We're missing cube, square. So I start out with a box and a line, plugging in the negative 2. What do I have? 3, negative 1, 0, 0, negative 5, and 10. Try the method. Let's bring down the leading coefficient. Multiply, add. Multiply, add. See if you came up with the same solution as I did. Sketch that first picture. Just have the 2 arrows pointing up in both directions. And there's some stipulations here, because as our polynomials get bigger in degree, when your degree is even, x to the 4th, x to the 6th, x to the 8th, we could have x to the 12th, the end behavior is going to end up like a parabola. But we're going to end up in the first and second quadrants only if our leading coefficient is positive. Look at that. Leading coefficient is positive. When we had quadratic equations, it depended on that a. If it's positive, it opens up. If it was negative, it opened down. Now I'm representing a sub n, leading coefficient. If it's positive, it'll be pointing up. In the next picture, you said it still kind of looks like a parabola. So that means the degree is still even, but your leading coefficient is negative. In the next picture, you said it's a line. So if you're a linear equation, your degree is 1. So if your degree is odd, x cubed, x to the 5th, x to the 7th, you're going to end up like this picture only if your leading coefficient is positive. And the last picture, it'll switch around, so your degree is still odd, but your leading coefficient is negative.